Hello everyone, in this demo we are going to introduce GraphGallery, a platform for fast benchmarking and easy development of graph neural network-based intelligent software. As an important data representation, graph is ubiquitous in many real-world applications. In order to represent and analyze graph data, graph neural networks have recently proposed as a powerful tool. They are playing an essential role in software engineering. To this end, a line of specialized GNN toolboxes have been developed for efficient training, such as PyTorch Geometric and DGL. Although these frameworks have eased the development of complex GNN models, they still come with steep learning curves. It requires developers to have necessary domain-specific knowledge, as well as certain scripting and coding experience in machine learning. Besides, most of them only support single deep learning framework, which is unfriendly for developers who use the different ones. We tackled the aforementioned problems by our proposed GraphGallery, an open-source platform for deep learning on graphs. In particular, GraphGallery includes the following features. It has unified and extensible interfaces, which allows unsophisticated developers to deploy GNN-based softwares automatically and develop new models easily. It has mainstream framework supports for both TensorFlow and PyTorch. It can also make model evaluation finished in a few lines of code. Here we provide an overview to GraphGallery. To run graph neural networks, we first have to define the input graphs. GraphGallery has already assembled a number of benchmark datasets commonly seen in the literature. Besides, it's also much easier to define and employ custom datasets with the provided interfaces. Here is an example for adding user-defined datasets for semi-supervised node classification task. After defining the inputs, we can start to build up the model. GraphGallery provides lots of essential building blocks for creating GNNs. It also provides lots of mainstream networks. They are out of the box and convenient to use. Developers can use them to deploy GNN-based softwares directly. Moreover, an indicator can be used to dynamically switch other framework backends. After defining the data flow, the complete training pipeline is applied to optimize the model. The training pipeline integrates several callbacks. Tedious work such as tuning parameters and resuming breaking points is automatically done by this platform. Once the model has been optimized, it can be used on a downstream task and assess its performance. Developers can use the same data flow or define a new one for inference. Here, we also consider the robustness and stability of GNNs, where several specialized methods have been integrated into the inference pipeline. Finally, GraphGallery will assess the model on the testing set and generate the corresponding report. Here's the code for the whole procedure mentioned above. First, we need to prepare the graph and split it into training and testing sets. Then, we can specify deep learning framework in one line without modifying codes below. Finally, we build up the model and run. Our experiments show that the implementation is reliable with fast coding. Thanks for watching. We hope more researchers and developers will use GraphGallery to accelerate their benchmarking experiments and software development. The project website is available at GitHub. If you have any questions, feel free to contact this email.